Hello guys, my name is Andrew Tengemano. Welcome again to my channel. It's been a long time since I have uploaded my videos in my YouTube account. So today I want to explain and to teach you on how to design box culvert by using manual and using Excel sheet and using Staadpro. If you are not yet download Staadpro, you can check my previous video on how to download Staadpro. So from there you can get it and you can use it in this project. So I have done this project by using Staadpro, by using manual, and by using Excel sheet. This is a kind of drawing which I generated after calculation and to show you and explain you so that you can get a better picture in this project. This is an example of drawings which I have already designed through this project. As you can see, this is a drawing. I have already prepared the bar bending shadow for final. I've already drawn the reinforcement details for this project. So in these classes, we will know how to designing this uh, this this project by using Staadpro, by using manual calculation, by using Excel. So if you're not subscribed yet to my channel, please you can subscribe to my channel so that you can get any update. So for starting, everyone know that how, like, this is a picture of books culvert, as you can see. So in my project I designed this type of culvert for Khudra street, but there are some protocol I should follow so that I can give them material so that you can get to download it and learning more about it. But for starting, I will show you on how to do this kind of things. Okay, so this is my channel, so you can you can go there and get to know how to download the Staadpro. I've already uploaded these two files on how to download Staadpro 100% free, and you have also to check this video on how to activate Staadpro Foundation. It's better for you to have this software for the analysis of structure so that you can use in different activity, not only in this project, also in another project like bridge designing, like building design. You can use this project for different structure analysis. So if you also, you may ask a question if you like your comment, and sometimes I have a lot of things. I'm not going to check my YouTube channel. It's better to go to my Instagram, so you can search. My name is Andrew Tengemano. As you can see, you can go to Instagram so that you can follow me. That's name Andrew Tengemano. So from there you can get in touch with me. So if you have problem, you can ask, you can follow my Instagram so that it will be better for you. For if you have any challenge about it, then I'll get into it at any time, which I'll get a free time. So for today, I want to show you, this is a introduction of this lesson on how to designing box culvert by using Excel sheet, by using also manual designing. So currently this is a Excel sheet which I have already do my calculation in there. I have already designed. So in this lesson, I'll teach you on how I used to design this, how procedure I use. Currently, I'm studying in India, so I'm using Indian code. So if you are from another country, you have to follow the code which guide in your country, because every country have their respective code. So In India, we use like IRC code for designing of road road structure. So in this project, I'm going to use IRC codes for designing. We use IRC codes. As you can see, this is the IRC codes in India we use. So I'm going to in this project I will use IRC code. So from this IRC code, we'll get to know how the code will help us to designing the component, to designing the all things which are included in designing of box culvert. So there are a lot of things to know. So, but in this project, you have to know how to draw. This drawing you will drawing by yourself. So you have to know how to draw the components by using AutoCAD. I think most of civil engineering student or you are expert from civil engineer, you have to know how to draw by using AutoCAD. So it's mandatory for you to know how to design, because this drawing is not designed automatically. You have by yourself to design this, you have to draw this, and you have to know which things you could input in your drawing. So you have to you need to have the knowledge about drawing in general, so that you can able to do this project. So before you ever started to design, you have to collect data, and so you have to do the soil test. So from the soil testing, we will need to have the following data. This is which is back dense to the soil and angle of internal friction. This data will help us on analysis and the design of box culvert. So you have to do the soil test. So from the storage shear test, you get the angle of internal friction, and after that you have to do another test so that you can know but back density of the soil. So after that, as you can see, I have already started on writing this document. So after finishing writing this document, I will upload it in website. So from there, you can go and download it. So let's start with manual calculation. For now, I will start with manual calculation so that you can get a picture from how to design this. And after that, I'll go to designing on by using Excel sheet. And after that, I'll go to design by using Staadpro. So please follow this procedure so that you can able to do these things by yourself. Also, you can be teacher for others who need help for this kind of project. So as you can see, this project it's done by me, and it's already submitted. So let's start for how we design. As you can see, this is a box culvert. This is a picture of the box culvert. As you can see, at the top of the box culvert, there is feed soil. There are feed soils, and from there, maybe car, people, and the other vehicle pass from there. And this is a dimension of the box culvert for 4,000 millimeters. You can say this is a hatch, and this is a forces which act on the box culvert. As you can see, I'll start to explain from the first stage to another stage. So as you can see, first you have to find the thickness of the components of the box culvert. So the components which we will insert and which will be constructed in box culvert, we have to find the thickness. So before knowing the thickness, we have to determine also the dimension of the box culvert. So from the dimension of the box culvert, we will get to know the thickness of the box culvert. So as you can see, I have done thickness of the box culvert is equal to 1/10 times inner culvert dimension. As you can see, inner culvert dimension is 4,000 per 4,000 millimeter. So from there, you will get to know that which thickness is needed for box culvert component. So after that, you have to get like a center to center dimension. As you can see, center to center dimension of all components, which is effective dimension, is 0.4 over 2 plus 4 plus 0.4 over 2. As you can see, the center of the this from center from this to the this, so the length from this to this, as you can see, the inner dimension is 4,000, and after that you have to take the half of the thickness and half of the thickness for the both end. As you can see, I have done it. So after that, you will get the effective length, effective dimension of the box culvert. So as you can see, the effective dimension of the culvert is 4.4 times 4.4. So we have to design hinge. We have to design hinge because yeah, this is in order to take care of addition stress at the junction of the culvert. So we provide the hinge at the inner edge of the culvert. So if the road is being applied into box culvert, there should be the addition stress will be generated at the corner of the culvert. So to counteract or to resolve this problem, we have to design hinge so that it help to remove that kind of problem. As you can see, as I have shown the drawing area, this is the hinge. Let me draw this. Okay, this as you can see, this is the hinge. This is the hinge. So for addition moment, for addition stress, we provide the hinge so that to counteract the addition stress and to remove crack to generating into our culvert. So after designing our after designing the effectiveness of the box culvert, we have to design of hinge. So the hinge, it will be that is equal to the thickness of the component of the culvert. As I said earlier, I have already calculated the thickness of components of box culvert. So from there, you have to define design of hinge. Design of hinge is equal to the thickness of the component. So as you can see, the thickness of the components was 0.4 meter or 400 millimeter. So I put here 0.4 meter. So as I said earlier, you have to the purpose of hinge to counteract the addition stress which generated due to the force acting on the culvert. Okay, so after that, we will go on how to load calculation. As you can see that culvert will be subjected by different load, and from this load, we'll design the adequate components and adequate reinforcement which will help us to resist this force and make our structure to be safety. So as I already stated earlier, I'm going to use IRC code. I've already shown that this is an IRC code. If you don't have IRC code, you have to download. This is Indian Railway, Indian Road Congress. So you have to download this according to the country which you stay. There are some codes which engineer used for design purpose. So in India, we use IRC code. So if you are using British code, you can use American code according to the code which your country use. So for now, I'm in India, so I'm going to use IRC code. This is the code we use for designing load components. So make it into a mind so that you can able to do the things which is adequate. So as I said earlier, after designing of hinge, after calculating the effective dimension of the culvert, we are going to look on load calculation. Load calculation, the load has been applied. As I said, the load has been applied at the top at the top, which is live load, safe weight of the slab, and the filling load. As you can see that the live load is loaded due to the components, it is due to the people, vehicle, and due to the maybe motorcycle, the difference load which is will act as live load. And we have also we will filler like we will get material from the other side and to fill the box culvert, and also we will have a safe weight of the culvert. So this load we have to calculate so that we can add and then to design our 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 culvert. As I said, I've not said it, but I forget about this. How which load we are going to use. In India we have different type of load acting on the road, which is AA load, BB load. So it's depending in which category of the road which you are going to use. So for me, I'm going to use a critical load, which is AA load. AA load for culvert is 700. So according to the place which you are staying, or according to the place whereby the culvert is going to be constructed, you have to define what kind of the vehicle which will be passed on that kind of box culvert. So from there you will get to know which kind of road. So in my project here, I'm going to use live load of IRC class AA. I assume that this culvert is permanent, and then I will not going to remove after maybe after a certain period of the life of this culvert. So I'm going to use IRC AA load. So first I have at the top is subjected by safe weight of the slab, live load, and filling load. The filling load from the material. We have to fill the box culvert. So safe weight of the slab W1. I think that this is the thickness of the grade, thickness times grade of concrete. I will use grade of concrete is 25 Newton per millimeter square. This is the characteristic strength of concrete which I will going to use in this type of culvert. So according, you may use any type of the concrete grade which you may use or which you will want. And I've already said that in my first talk about back then, that I'll say that in this project I will use 14 Newton per meter cubic. So you have to conduct the soil test so that you will know the type of the soil, so that it will be helpful on your calculation. So that it is. So as we can see here, thickness times grade of the concrete is 0.4 times 25. Then I get to know it is 10 kilonewton per meter square. Also filling loads is 14 kilonewton per meter square, and the live load is the intensity live load. So from IRC, as I said earlier that in India we use IRC load, and how to calculate intensity live load. Intensity live load is equal to 1 plus IF into W over BD times LOD. So this is a formula which will help us to determine the intensity of the live load which will be passed on the box culvert. So in a IRC IF intensity IF is equal to 24%, and the IRC 6, when you take IRC 6 2017 close to 08.3, page number 3, you'll get to know it is 25%. And the load for AA is equal to 700 kilonewton. This is the load for AA load. So impact factor for span up to 5 meter is 25. So you know our span is 4.4. So if the span is up to 5 meter, we take impact load is equal to 25% of the span. If the span is 9 meter, if the span is 9 meter, you will take impact load is equal to 10%. But if it is between from 5 to 9, we take the linear interpolation, as you can see. So if your span is range from 1 to 5, 1, 2, 3, 4, 5, or 1.1, 1.2, 2.4, up to 5, you have to take 25% of the span. So, and if the span is 9 meter, you have to take a impact factor as 10%. So if your span is range between 5 meter to 9 meter, you will take a linear interpolation. Then, as you can see in my project, my span is 4.4. I've already started. This is 4.4 here. Yeah, effective span is 4.4. So I will use 25%. So as I already said that, length of dispersion is equal to contact length of the wheel plus 2 thickness of the slab plus wearing coat. So contact length of the wheel plus 2.6 plus 2 thickness of the slab plus wearing course. As you can see, contact length is 3.6. As you can see, 3.6 is 3.6. Okay, let me show you 3.6. Yeah. Okay, contact length. Yeah, 3.5.6. This is a constant from IRC code 3.6. You may ask where I get 3.6. If this is a constant, so in another video I will show you how 3.6 is to obtain from IRC code 4. For now, I will show you how to design length of dispersion. So 3.6 plus 2, as you can see, thickness of our slab, I have already calculated 0.4 plus 0.1 is wearing cost. So wearing cost, you may say, how can I get 0.1 as a wearing cost? Wearing cost is taken from 80 millimeter to 100 millimeter. So you may take a 0.8 or 0.9, or so it have to be a range between 80 millimeter to 100 millimeters. So it depends which you choose. So according to me, I will take it at 0.1. So it's according to, as you can see. Then after that, you have to take the addition of this value, 0.5 plus 0.1, you get 0.5. Then you also, after that, you get the 4.6. As you can see, 4.6 is greater than effective span. Effective span was 4.4, and the length of dispersion is 4.6. So which say that the effective span is a critical value. So as you can see that length of dispersion is greater than effective span. So we cannot use 4.6. We will use effective span, because 4.6 will not get 4.6 in our structure. In our structure says that the critical effective span is 4.4, and we get the length of the dispersion 4.6. So we can not able to use 4.6. So the length which we will get from our structure is 4.4. So we will take the 4.4 as we calculate area as a effective dimension of the culvert was 4.4 times 4.4. The distance of all components of all effective dimension is 4.4. So we neglect 4.6. So if maybe it was maybe 4.3 or 4.2, we may take as 4.6. So it should have less an effective span. That's why it's greater than effective span. That's why we will put that 4.4 as a length of dispersion. Also, after that, after calculating length of dispersion, we have to calculate in that width of dispersion. So after calculating this value, are we going to use how we calculate length of dispersion of or width of dispersion? What is important of this length of dispersion and the width of dispersion? Mm. So width of dispersion, this is a dimension of dispersion of the load along with of the load. So dimension, this is the dimension of dispersion of the load along with of the bridge. So the value of LOD and BD help us to get the total area whereby the load of vehicle acting. So this BD and LOD, it's act to the total area. So the area whereby load acting into our components, which is box culvert, so that to find this area is it may be it is good for load to pass, or we'll have to add some dimension, or we'll have to maybe to minimize dimension. So in order to make the decision, we'll have to find the length of dispersion and the breadth width of the dispersion. So this is a total area whereby the load acting. So vehicle load is acting at the area of LOD and the BD, which is the length of the dispersion and the width of the dispersion. So this is I'm trying to drawing this so that you can get a clear picture about how length of dispersion. As you can see, this is length dispersion from there and there. This is the whole span, and from there, from here to here, this is length of dispersion. This is the wheel contact with it. This is whereby the vehicle will be contacted with our box culvert. This is a wearing coat, as you can see in this diagram. So this is so the after that, I'm going to show you on the effectiveness of length of dispersion and the width of dispersion. What the impact of the length dispersion and the width dispersion. As you can see, this is the area. This is area before we include the length of dispersion. So if we are not including the dispersion, it is that the road will act at this area only, this area, the inner approach. But it's not true that the load will act on this into this area. Also, the load will act all in our component. As you can see that after we include the length of dispersion and width of dispersion, we'll get that to know that this is the area whereby the vehicle, the load of the vehicle and other load will act into components. So this diagram is help you to know that what is the important, how we calculate length of dispersion and width of dispersion. What is its importance to us? So as you can see, this is before we include the length of dispersion. This is after we include length of dispersion and the width of the dispersion. As you can see, though this is a drawing which I have shared so that you can get to know about what is the importance of length of dispersion and the base of dispersion. So this is the result. This is a drawing. This is a drawing is I get from IRC 6200. So I will get, you will get to know later on how. Okay, as I said earlier, that this drawing is from IRC. For IRC, you'll get to know this type of drawing. So let me show you IRC. This is the IRC for loading. As you can see, this is the IRC loads and the loads combination. You can Google and get it. And as you can see, this is what is it? IRC says that wheel arrangement for 7-yard wheel vehicle. So this is 0.85. There are some space in 0.85. This is drawing as I said that I get from my IRC and C. What is the value of C? As you scroll down, you'll get to know for class 7 loading is applicable only for bridges, and we use bridges. We design the bridge components, which is a design of culvert, and the value of C should be 1.2 meters. This is according to IRC loading and load combination. So for my IRC load and load combination, you see that the minimum clearance between the outer edge of the wheel or track passing or course vehicle mat line bridge shall be 1.2. Vehicle passing or course can be either the same class or different class traffic or wheel class. So as I said earlier, I will use IRC for IRC code for design. So I think you will already know. So value of C is 1.2. So after that, we are going to calculate the BEF, effective dispersion for the single wheel. This is a single wheel. Let's the single wheel. So we are going to find the effective dispersion for the single wheel, which is equal to BD. For BD is equal to BAF over 2 plus 2, 0, 5 plus BEF over 2. So we are getting 2.05. As you can see that the half of 850, when you take half of it, you'll get 425, and there also 425 and plus 1.2. So when you place, you will get that 2.05 as I showed here. So BF is equal to effective dispersion for single wheel. So effective width is equal to effective dispersion for the single wheel over 2 plus 2.05 plus 2.0 plus effective dispersion for the single wheel over 2. So 2.05 I get from, as I say that this is drawing is from IRC, and I already show you that this is how you can find, you can Google IRC loads and loads combination as it's saying 0.85, 0.85, then this is a load, which is this is a wheel, this is a wheel, this is a C, and I've already stated that C is equal to 1.2. This is according to IRC loads combination. So in design, we usually using code. Code is our direction. It's our map towards the success of our structure drawing. So after knowing that we have for the effective width of dispersion is equal to effective dispersion of the single wheel over 2 plus 2.05 plus effective dispersion per single over 2. So total, this is the BD is the total length of the dispersion. So as you can see, this is BEF is equal to this. We've already started is equal to 2.6. This is the angle x brackets 1 plus x over effective span, which I denoted as L plus D W, which is the contact dimension of the wheel along the width of the bridge. So as you can see that this formula of BEF, this x is equal to span over 2. As I've already stated, this value of this, how we can get the value of this. You can see that this as I said is that, let me start it from step by step. Let me finding x. X is equal to span over 2. As you already calculated, span is equal to 4.4 over 2, which is equal to 2.2, and also LO is equal effective span. So BW is equal to contact dimension of the wheel along the width of the bridge plus 2 brackets wearing course. As if you already say that this is equal 0.85. This dimension which is in drawing is in millimeters, so we must change into meter. That's why I put 0.85, and I have already shown where to get this value from IRC loads combination. As you can see, this is the IRC loads combination 0.84. So I put in my drawing IRC 0.85. It's okay. You can put 0.84 or 0.85, no issue. So let's get to a calculation. As you can see here, how I do my calculation. So contact dimension of the wheel along the width of the bridge. This is the 0.85. As you can see, 0.85. Okay, 0.85 plus twice of wearing coat. Wearing coat, I say that you can use from 30, 80 millimeter up to 100 millimeter, is up to your choice. So my choice, I will use 100 millimeter, as you can see here. So after that, I got 1.05. So after that, 1.05, and so B is equal to total width of slab carriage plus fronting. So we have to find the value of B. So from the value of B, we have to get the value of this angle. So from this, we are going to insert it into our formula so that to get the value of BEF. As you can see, B over L. B, we have to go to take that 1, as you can see. As you can see, 1 plus 3.5 plus 1 over effective length. Effective length, which is 4. Okay, this is not 3.5. This is a 7.5. 70. You may ask here, how did I get 7.5? 7.5, as if you are already studying into transport for two lane. For two lane, the length which you will take the width which we will use is 7.5 from IRC code. So I don't know the code which you're going to use, but for Indian code we use 7.5. So if you will use it two lane, 7.5. Maybe if for one lane it should be 3.5 or half of it. So in this project I assume that our load is two lane, and therefore the two lane is 7.5. And after that, when you take that one is meter, whereby the at the left and the right side, whereby the people or bicycle, so then they may pass. So we take it 1 meter, one meter left and the right side of the road. So, and this is 7.5 is for two lane. For two lane load, we take we assume as a 7.5. This is according to IRC loads, and if you are familiar with the transportation engineering, you will get to know these kind of things. So after that, let me show you how to get this value 2.6. As you can see, this is from IRC. So let me show you IRC for code. So from IRC code, so you have to download it if you are going to using Indian code. Let me show you. As you can see, the formula which I have already show you is this is the formula A, or this is the formula. As you can see, this formula. You can say, where did I get this formula? This is for formula also I get from the IRC. As you this formula. is this formula. You may get using a RC code, this. As you can see, this is a code which we use for designing. So as you can see, it's called this constant, a constant of okay, yes. Yeah, this is a constant having the following value depending upon the ratio of B over L. As you can see, let me increase this value. A constant having the following is depending on upon the ratio of the B, whereby B is the width of the slab, and the L0 is the effective span. So effective span. So how we determine the value for simply supported slab? As you can see, as a value of 0.1 B over L is 0.1, the value of this will get 0.4, 0.8, so 0.1. So if it's between 0.2 maybe and 0.3, you have to interpolate and get the answer. So you may use for continuous slab. This is a value for continuous slab, and this is a value for simple supported slab. You have already that continuous slab is a slab which has more than one supported. So according to your designing, you will categorize your design as your slab is a simple support slab or continuous slab, as you can see. So as you can see, for the value of this, as you can see, from 1.2 for 0.9, you should be this, you should be this, you should be this. As you can see, you after 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, and 2 and above. If your value is 2 and above, and our slab is continuous slab, so if your value B over effective length is greater than 2, the value should be 2.6. So 2.6. So that's why in my designing, as you can see that the value of B over is greater than 2.15. So that I took 2.6, as you can see, BF is equal to 2.6 times 2.2. I've already explained how to get this value. 2.2 x span over 2, 444, 2.2, 1 minus 2.2, as those things I've already calculated previously. So after that, you will get in to know the value for effective dispersion for the single L. So effective dispersion of the single L is 3.91. So after that, we have to divide by 2. So after dividing by 2, this is 3.91 over 2 is equal to 1.55. So we have to check if this, we get that from our calculation from the code, should be this. So we have to also to know in our read structure, can we get that's kind of the this we can get. So this should be minimum according to the available space from the center to center of the culvert. As you consider 1 plus 1.2 plus 0.25. You may ask here, how did I get this? So as you can see in the drawing, this is 1.2 and a half of 850 half, getting 425 millimeter. So we have to change into meter. You get 0.425 plus 1.2 plus 1 plus 1. As you can see that the half of this 1.2, this is in term of millimeter, so we have to put in into meter. As I'm done now, as you can see, 1 plus 1.2 plus 0.42. So you can see it's 2.625. Okay, as you can see, this is greater than this, so it's okay. We can use this value for calculating the effective breadth. As you can see, so 3.9. So if this value is greater than this, you have to take this value. So this value must be minimum when you compare with available space. So available space is our critical space. This is emerging. So the space which we have calculated theoretically must be the minimum when we compare to the available space from the center of the left well. So BD is equal to 3.91 over 2 plus 3, then you get that effective width as 5.96 meter. So intensity of the live load, as you can see, is 1 plus 0.25 plus 700. 700 is, I've already explained how I put 700 is, this is the AA classic load, and then BD, and for intensity live load, this is the formula for intensity live load. Intensity live load. Intensity live load. Yeah, intensity of load. IF, I've said this, IF is 0.25. 25 for our span is less than 5, so that's why I took 1 plus 0.25 times W. It was already started in IRC. For the IA load is 700, so that 1 plus 0.25 and bracket 700 BD we have calculated, and the LD we have calculated. So how to find the intensity load? That's the formula, and that is how I used to calculate the intensity of load. 1 plus 0.25 plus 705.96 BD, and the L O is the effective span. So intensive live load is 33.4 kilonewton meter square. So the total load on the top of the slab. So at the slab, the load which acts at the top of the slab, it will be safe load, safe weight of the slab, plus filling load, which is back density 14 plus 33.4. So total load on the top of the slab will be this. So for today, this is a first chapter. This is the first procedure on how to finding the load at the top. So from second episode, we'll have to design on how load on the walls of the slab, on the side wall of the slab. For now, the total load on the top of the slab we get then 57.4. This is due to the safe weight of the slab, filling load of the slab, and live load of the slab. Live load of the slab is equal to the intensity of live load, and I have already explained. So from this video, if you face any problem, please, you may contact me in this channel. You may ask, we may share the concept together, or if you maybe you write a message and I will not answer in time, you can check me in my Instagram. You can search my name, and we can discuss more things. So for today, for this lesson, let's end here, and then I'll come to another episode, and don't forget to share with others, to like it, and to subscribe also if you see this is important for you. Thank you.